Thanks, Adel, for coming up on the show today. Before we begin, would you like to introduce yourself?
Yeah, thanks, Chenin. Great to be here. So my name is Adel El Hallak. I'm a director of product management at NVIDIA. So I lead a team of product managers and technical marketing engineers for the NVIDIA NGC registry.
All right, awesome. And could you describe what is the NVIDIA NGC?
Yeah,
and could you tell us about that?
Yeah, sure. So NVIDIA is a software hub. Our objective is to facilitate and accelerate machine learning and deep learning workflows by providing data scientists and developers with artifacts that allow them to concentrate on what they do best, right? Which is data science and deep learning, rather than spending any time taking care of any plumbing or setting up dependencies. It is a software hub of not just NVIDIA's software ecosystem, but it is also of our partner ecosystem. So ISVs that GPU accelerate their applications, their building blocks are also hosted on NGC.
Mm-hmm. Right. Could you provide some examples, like what kind of software is provided on the NGC?
Yeah, look, you know what, Chenin, I think rather than just talking about it, how about we just show you? So
awesome.
if I may, I'm just gonna share my tab. Can you see my screen okay?
Right, perfect.
Yeah, awesome. So NGC started in 2017, and it was a container registry for deep learning frameworks. That's what it was launched as. So every month, our deep learning team takes top-of-tree TensorFlow and optimizes it for our GPUs, right? They get the right GPU drivers, the right dependencies, all the related libraries, and optimize them and push them to NGC on a monthly cadence. So you can see here we have all the popular framework, whether that's TensorFlow, PyTorch, MXNet, and others. And like I said, every month, these are published and posted on NGC. And we do tons to make them performance optimal, make sure they get the latest features from NVIDIA. We do things like test them across different platforms. We make sure they scale from single GPU to multiple GPU, and often multi-nodes. We scan them from a security perspective to make sure there are no vulnerabilities. So really building to make sure that you get the best of our optimizations directly from the registry. That way, right? I'm not sure if you've ever had the opportunity to or install TensorFlow or PyTorch from the open source communities. You can appreciate it take some time figuring out the right level of dependencies, right? And so really by doing this on a monthly cadence, I'm going to pick on PyTorch for a second. If you notice, like I said, every month we publish a new tag for PyTorch. So December was our last one. We had one in November, etc. And by doing this, Chin, essentially what we're doing is we're making sure that data scientists don't spend that time on the plumbing, right? Figuring out and setting up their environment. We want them to be trained from the get-go, right? Or building their. And so that's why we have this recurrent cadence of building, optimizing these open source frameworks and posting them on NGC. But Chenin, guess what?
Right.
We quickly realized that containers wasn't enough.
Oh,
right?
Okay.
Right? Containers isn't enough. Typically, when you're building a machine learning workflow, right, or a deep learning workflow, you have an entire workflow, and that entire workflow spans everything from a data engineer, the data scientist, the developer, to DevOps. And if you're working at an enterprise or a university, you have to deal with system admins as well. So we started looking at their overarching workflow. I quickly realized that, people don't build workflows with just a container or a model. It's a bunch of different artifacts that have to come together, right, to be able to realize value, if you will, with deep learning. And so in addition to containers, I'm going to come back to this notion of collections in a bit, we also have a model registry. So a model registry that spans all sorts of different tasks. So if you want to do recommender systems, if you want to do anything related to computer vision, If you want to do things related to genomics, conversational AI, ASR, text-to-speech, natural language processing, medical imaging, naturally, is a big one. So we have all these pre-trained models, checkpoint files, if you will, hosted up on NGC. And so data scientists, rather than taking a model and building a model from scratch, so NLU is a big topic for us nowadays, right? Or a big focus area. We provide a pre-trained BERT model, in this case here for TensorFlow and Save model format, and we host it for you. We don't want you to spend time training a model from scratch, right? We want you to just take that model and train it and adapt that model or fine-tune that model for your specific use case. And so by doing that, we're allowing these data scientists to build AI fast, right? Not having to do things from scratch. And I think what's really, really important, something I'm very proud of, is that in addition to hosting the models themselves, we also provide you with all the know-how of how we train that model. Reproducibility is a big thing for us, right? Transparency is a big thing for us. So what data set did you train the model on? How many epochs did it run? What kind of precision did you use to train that model? In case somebody chooses to want to reproduce that model themselves, they could do that. So let me stop right there for a sec. We talked about containers, optimizing those, right, with all the dependencies, all the libraries that are there, posting them up on NGC. And then a catalog of models as well across all sorts of different domains. And I know right now this looks a bit daunting because we've got tons of models. There are a couple hundred or more.
Right. That's good.
We think so, right? And it's growing, and it's growing quite fast. But again, I want to just continue touching up on this notion of sharing our know-how. Bear with me here on the right one. In addition to providing the pre-trained models and the parameters for how we reached it, again, we also provide step-by-step instruction for reproducing the state-of-the-art models that we provide, right? Here I'm picking on computer vision, ResNet, right? ResNet is like the Hello World 101, right, for AI. So we tell you, hey, this is what the model architecture is about. If you want to reproduce this, these are the prerequisites you need to clone, set up, etc. We tell you how to set up the repository, some additional advanced functionalities. But essentially what we're providing you here is everything you need to reproduce that model. Script, right, for data set augmentation in case we need to do that. We tell you what to set your learning rate at, what the performance will look like against a single GPU, etc. And so you not only have the model itself, but you have all the other artifacts in addition to the parameters to be able to read. And again, like I said earlier, it spans all sorts of different use cases. Again, just picking on the ResNet first deck, right? Like I said, we tell you what the model architecture is. And in the file browser over here, you will have everything that's required to reproduce what we posted up on NGC. But Janin,
yes,
hopefully, right? I purposely took you through this daunting UI for a reason, right? Because we have tons of models and tons of containers. We quickly realized that this was causing a user experience challenge. How do I know what to find? Hey, when I'm building AI, I'm trying to solve for business use case. I'm trying to solve for operational efficiency. I want to get a competitive advantage. I want to help the world overcome this COVID craziness that we're going through. And so this new notion of collections came about. And collections is really about bringing together these containers, these models, these resources, all these different code snippets, right, into one overarching umbrella that is use case driven. So I want to do recommender systems. Great. Guess what? We got a collection for recommender systems. It talks about what recommender systems are, tells you about the challenges and opportunities and how deep learning works in this domain, right? But more importantly, or equally important, is it provides you all the containers, the models, and the resources that are associated with recommender systems. So you can see here, you could do it in PyTorch or TensorFlow. Similarly, here we got models that span both PyTorch and TensorFlow and resources accordingly, and different types of models for recommender systems. And again, our collections span everything from horizontal use cases, so things like image classification, again, explaining what image classification is, and then quickly jumping into the different entities that help you do image classification. So again, here we do it in MXNet, PyTorch, and TensorFlow, and all the different models associated with that and the correlated resource. So really focusing on enabling use cases rather than saying, yep, go try to solve this with this TensorFlow container or figure it out yourself.
Mm-hmm.
Let me stop there for a second, just make sure if you have any questions.
Yeah. So like my first thought is that this is very impressive. I really like the fact that like all of the Docker, all of the containers, I think they're probably based on Dockers. And like I saw briefly, like you have this wget, and then so essentially we could just copy the commands, paste it into the terminal, and then follow along. And the documentation is pretty nice. And there's a lot of collection of software. And I noticed that there are some that are in my domain. I'm coming from like a computational drug discovery background. And so I noticed there's VMD, NAMD.
Yes, sir.
Right. And a lot of other like medical informatics container, like Clara. I think one of my colleagues at a medical faculty, they're also using Clara. Yeah, so I'm not sure if I'm correct, like we could essentially just copy paste the commands that we saw, like wget and then like the URL, input, output. And is that all to run it?
Yeah, that's exactly, we're trying to make it as easy as possible, right? I think good engineers build products to help other people become as lazy as possible, is how I always joke about it. You're spot on, right? If you're doing a container and microevolution or NAMD, what we do is we surface the container pull command. Yes, if you have a Docker client or the NGC CLI, you just come over here and you suddenly have the Docker pull command. In a similar vein, for our models, if you find a model for UNet, you've got the wget command. You can just click that here, it copies it onto your clipboard, or a CLI command if you're using the NGC CLI as well. So yeah, absolutely, we're making accessibility of those as easy as possible. And in a similar vein, you can also download and pull an entire collection as well, right? So if you want access to all these entities, there's a means for you to be able to pull all these artifacts into your onto your machine as well. But Chanin, you touched up on Clara, and I'm glad you brought up that example, because Clara is one of those examples where it really allows us to demonstrate the value of NGC, right? Which is, you have a Clara Train framework, and you have a Clara Deploy framework, and you have Clara Genomics, and then you have other packages around discovery. But just talking about Clara Train as an example, right? There's a framework built on top of TensorFlow that essentially comes with a wide range of pre-trained models to recognize anomalies in different organs, right? Whether that's CT scans of lungs to identify anomalies there. Bear with me while I would query. Right. So and we've trained, I think, 1,000 images in collaboration with the NIH, and we're providing those models so that folks can, frankly, collaborate and help battle this crazy pandemic that we're living through. But essentially, is you get all these pre-trained models. You're not training from scratch, right? And they span different segments. Spleens, different organs. Spleens, livers, brains, lungs, etc. And so going back to the collections, when we go to Clara Train, right? In the entities, you have the Clara Train SDK, which leverages this technique of transfer learning, and then you have the associated models that we have. Again, many of those trained, one of those trained in collaboration with the NIH. And then we provide additional resources in case you want to intro course the Clara Train, and then you also want to do federated learning across different hospitals. But I think, again, going back to this, I don't come to NGC because I want TensorFlow. I don't come to NGC because I want PyTorch. I come to NGC because, hey, I want to help this hospital, this research facility, be able to identify right? Leverage AI to be able to identify and spot anomalies in organs faster. I come to NGC because I want to build a recommender system for retail. I come to NGC, I want to solve use cases and business problems. So this is why we're framing everything in the context of collections.
Right. I mean, this sounds very good. And is like, how much is this? Is it free, or is it a subscription based a service, or?
Yeah, Chen, great question. Today, all the NVIDIA software, NVIDIA public software on NGC is free of charge. Right? Again, we're building on top of open source, right? We're optimizing open source for the community. So yes, today it's at no cost. That's not to say on NGC, all of our software from our ISVs is also free of charge. So you might download, something from MathWorks or MATLAB, right? You'll get the application, you'll be able to use it for about 30 days. But after that, you have to contact MathWorks and get a license renewal to be able to do that, right? Now, the application that you get has been GPU optimized, and you do get to take it for a test drive. But at some point, some ISVs, they're paid for applications, so you'll go back and kind of renew the license. But from an NVIDIA perspective, yeah, right now, today, a lot of this stuff is trained on open source, right? Like computer vision models are trained on ImageNet. Why? There's costs associated for us to train those models, but hey, we don't want you training something from scratch, right? We want you changing the world with the AI. So we're giving you the building blocks for free, and then we want you to create the amazing use cases that we're looking at.
Yeah, that's awesome. And I was wondering, like, for example, like if someone wanting to dive into the NGC, is there like a tutorial, like what you have provided, but then like more in depth, maybe like a step-by-step, like in order to implement or deploy a certain model?
Yeah, absolutely. So there is a getting started collection. It teaches you how to pull the TensorFlow container, lets you do an MNIST example, right? Handwritten numbers. I think that's probably the first deep learning example that I've ever done in my life. And then we also give you some, set up Jupyter notebooks. But yeah, we do have a getting started collection, which we think is a fantastic way for folks to get used to doing Docker polls, wgets, etc. And it goes into quite details. Hey, here's developer forums you might want to tap into. Here's our CLI. Make sure you set up our CLI. We've got additional documentation here for how to use the container registry, the model, and Helm charts, which is something we didn't speak about much. But yeah, we are absolutely looking at providing not just tutorials for beginners and entities for beginners, but also making sure that we publish a lot of Jupyter Notebook-based examples that show how to solve for specific use cases from beginning, all the way up the line. More proficient.
Yeah. Right. And I was wondering, you mentioned briefly that this catalog, third parties could also contribute to this as well.
Absolutely. Like I said here, we talked about MATLAB. They've been a fantastic partner of ours. But it spans a lot of other companies as well. Let me see, we've got the Plexus guys. Yes, I mean, others can contribute to the ecosystem. Recently, we got Folding at Home, which is open source. Sony has a neural network libraries framework up here. Some ML ops companies, I don't know if you're familiar with that term, but as companies adopt AI in production, this terminology on ML ops, operationalizing AI is big. So we see a lot of these ML ops type of organizations come and host their platforms on NGC because they see the value in leveraging our containers as runtime. They see value in leveraging our models, as for their workflows. And so we're seeing some of that partnership and them starting to publish their applications on NGC as well.
Right. And I noticed that most are companies, could individuals or research group from academia, could they also contribute to this catalog?
Yeah, absolutely. Like I said, we collaborate with the open source communities. We collaborate globally across the other companies. I talked about the NIH example.
Right.
Work with supercomputing units. So yes, it is not restricted to enterprises, etc.
Okay.
Frankly, this, some of our biggest users are researchers, right? So tackling
Okay.
the world's hardest problems.
Awesome. Yeah. I noticed some keywords popping up like chem informatics, GrowMax. So I think I could definitely give this catalog a try. Maybe do a future YouTube video showing like how to use this in a real world setting. And yeah, I'm very impressed, and I think it will be useful for beginners and practitioners of machine learning and deep learning alike. And I particularly like the fact that this platform allows reproducibility,
Yes.
and I mean it's based on Docker, the container, and you already have like all of the underlying details of the models provided, like what parameters are
What parameters?
uh,
Absolutely.
right. And so, but I'm just wondering one thing is how much of a is there any prerequisite like for the graphic card? Like, do we need like a high-end graphic card to be able to use this, or will it work with any NVIDIA graphic card?
Yeah, I mean, we support Pascal and later GPUs.
So, like other brands could work as well?
No, so it is absolutely limited to NVIDIA GPUs. I mean,
I see.
that's our bread and butter.
Optimized. Yeah.
Right? It is.
Mhm.
I mean, that's the value, right? It's a
Right.
prerequisite to get on the NGC catalog, which is make sure
Right.
that you're, taking advantage of all the features that we have in our latest GPUs. So
Right.
Ampere architecture. Make sure you
Hmm.
capitalize on the tensor cores. Make sure
Right.
you capitalize on sparsity. Make sure you capitalize on MIG. And so yeah,
Okay.
everything is built and optimized for our GPU infrastructure.
Right. So yeah, so the performance is optimized for any model of the graphic card. Yeah, that's awesome. Right. Recently, there was an announcement that NGC was offered on the AWS, Amazon Web Services. Could you provide some information about that?
Yeah, absolutely. NGC seen tremendous success, Shannon.
Right.
The past year, now that 2020 is done, we had 250,000 users pulling more than 1 million downloads. A lot of those were from, the call it the on-prem ecosystem, but we also saw tremendous growth happening in the cloud.
Hmm.
And so in partnering with the large CSPs, and we made this announcement back in October, our CEO made the announcement back in October, we have this concept of store within a store, right? So the idea there was the CSPs came to us and said, hey, our users are asking for this container, and you bring this container to your marketplace. Hey, our users are really interested in this model. Our users are really interested in your Clara Train framework.
Hmm.
And so the ability to publish and maintain on these different marketplaces started becoming a challenge. So we came up with the notion of, hey, why don't we just lift and shift higher store presence and bring in the CSP marketplace, right? That way you don't just get a container here, an SDK there, model there. You're going to get access to all of NVIDIA's software.
Hmm.
Amazon is the partner that we've made progress with. And just in December, right before the holidays,
Right.
we announced the first implementation of bring the store within the store.
Hmm.
And so what this really means is, let me share again and show you. This is a how-to example, and I'll make sure I share this how-to example as well. I'm on the AWS Marketplace here, right?
Right.
And
Right.
you're seeing our container portfolio happening down here. It doesn't look identical to NGC, so this is just the first implementation of it. But you can see we're on the AWS Marketplace, and we've got our portfolio of optimized containers over here. Now, they don't have this notion of collections, but they definitely believe in leading with use cases. And so what we have here is we have filtered that act somewhat like collections to allow you to be able to filter through and find the associated artifacts for you, right? So why did we do this, Chino? Why did we do this?
Right.
Us to deploy, NVIDIA software on CSPs, you have to navigate two different portals. I'm on NGC, I gotta find NGC, copy the command there. Oh, I gotta download the NGC CLI, then I got to go to AWS, set up my EC2 instance or my EKS service or my, right? And so we said, well, how do we improve everything from discoverability to deployment,
Right.
And so that was the underlying reason for this initiative, right? Is make this easier for our developers to not just discover the software where they actually want to deploy it, but make sure also that the deployment of that software across these different CSP services is also made easier. So for example, AWS is investing a lot in SageMaker, right? Their ML platform as a service capabilities. By bringing a store within their store, our containers now are natively hosted in ECR, their Elastic Container Registry. And so if you want to use any of our containers and spawn up a Jupyter notebook with SageMaker, you no longer have to take those containers and bring them into ECR. They're natively already. So even from a deployment perspective, Shannon, we are reducing the number of steps that data developers and data scientists want to do. So it's really a reaction to us listening to what our users are telling us, which is, hey, bring me closer to the compute, so that we can make the whole experience from discovery to deployment more. Like I said, we do have a technical blog that went out yesterday. This shows how, and I'll share this link, but this shows how you, now that NGC is in AWS, take our Train inference server and then be able to deploy it on EC2 instances. And again, we tell you everything, right? The prerequisites that are required, what the Train inference server is about, how to download the models, get pre-trained models, etc., and then ultimately do image classification on NVIDIA. It's a how-to example, which is another one to kind of similar to how to get started, but you can expect a lot more of the artifacts and how-to blogs coming our way.
Awesome. Right. I'm wondering, is this exclusive to AWS or is it also available on other cloud providers as well? So
great question, Chinan. The catalog itself for this implementation today is only available on AWS. We are partnering with the other CSPs. I'm not future knowledge. This was announced back at GTC in the fall. So the store presence, this notion of store within a store, right? Wait, I think I was really excited because we're the first organization for AWS to have its own dedicated section in their marketplace. So we're quite proud of that. But that doesn't mean you can't pull software and run it on other clouds. Like I said earlier, you just have to navigate two portals. And that's not to say that we don't have some pieces of our software on other clouds already, right? So you will find Train inference server, on Google's or Azure's marketplace, right? So, but this concept of our entire catalog is only available on AWS today. Again, we only announced in October of engineering work, so a lot of exciting coming down the line.
Awesome. Yeah, I'm very excited to give NGC a try as well. And and I think it will particularly be useful for academia, because like one of the priorities is for reproducibility. And actually last year I've written a review article about reproducibility in computational drug discovery. I mean, one of the challenges of research is that when we're documenting the research, like particularly when we're writing Jupyter notebooks or when we're writing the data science workflow, I mean, the small details is not shared in the materials and method, and so a lot of the things are not in there, and so that could lead to irreproducibility of the work. And I mean, my first impression from the NGC is that aside from the container, you also have pretty good documentation, and I think that that's one of the best things. The various use cases that NGC provides looks pretty impressive, like from NLP, image classification, and also to even like molecular simulation. So yeah, I think it's worth a try for both people from industry or from academia, and as well as from the teaching perspective, educational perspective. Like you have like the example of getting started and on how to use the MNIST example and other like the BERT model as well. Yeah, so very impressive collection.
Yeah, thank you. No, I appreciate that. Yeah, absolutely. That's one of the key focus areas for us, which again, we can't solve for biases. The whole world is working
Right.
on, interpretability, explainability.
Right.
But what we can do, Chenin, is be as transparent as possible, right? Be as transparent as possible. And that's
Right.
a key focus for me on 2021. Transparency across two different dimensions. Transparency from a security perspective, right? Just, these. So we scan everything before it goes up on NGC, et cetera, make sure there's no way it can be exploited for the latest CVESs. And we want to make sure we make that, you have access to all these reports. Similar vein, for any models that we provide, we want to provide that transparency, right? And make sure that folks are thinking about not just the benefits and the awesomeness of the model, but potentially the limitations of the models as they can relate to not just performance, but potential biases as well. So by making sure we're telling you exactly what we use, how we built it, et cetera, I think we're going to not just enable folks to build awesome use cases with AI, but I think they'll do so responsibly and hopefully with ethics in mind as well.
Right. Yeah, that's a very important issue. Yeah. Can we maybe talk a little bit about, like, for those interested in using NGC, could you tell us a little bit like how they could potentially get started? And for those who want to use NGC from within AWS, do they need an account for that? I mean, is there like a free trial to test out NGC or?
Yeah, Chimin. So as it relates to the catalog itself on NVIDIA,
right.
No, like I said, if you're not if you're not going after any of the enterprise-based software, right? So you're going for this portfolio. Yeah, all that software is available free of charge. Some of it requires authentication for, but otherwise, like I showed you, I wasn't logged in. You saw my the Docker pull commands, right? We want to make this as easy as possible, eliminate as many steps as possible. Now, the cost or the associated cost comes for when you want to deploy that software. You need access to a GPU. You might have one, on your workstation, which is great. But like I said, a lot of folks try stuff in the cloud. So if a provider gives you credits because you're university students, you can absolutely use those to deploy that software for free. But again, there is a cost associated with the instances that are in EC2 or the services that are, on AWS. You're charged for that cost unless you have. But of downloading the software on your local machine, if you have a GPU, and hopefully you guys do, then yeah, all accessible. You just go to ngc.nvidia.com and Docker pull or wget away.
Right. Yeah, that's awesome. Yeah, crystal clear. Thanks for the clarification. And another question that I have in mind is there anything to expect from NGC this year? I mean, you have such an awesome collection right now. Is there going to be more awesome developments coming up for 2021?
For 2021, can't speak too much to the future, but I'll tell you what I'm focused on. Right.
Right.
Certainly, again, you see, we talked about transparency, just making sure that from a security perspective, from a compliance perspective, understanding all the licenses that are there, limitations of the models, parameters of the model. So that continues to be a big focus for us.
Right.
Obviously, you'll see a lot more collections that'll be tailored towards use cases coming about as well. Video broadcasting being one of them. More things related to conversational AI as well.
Right.
The other thing that I think you'll see us also start to do is we're always thinking about how do we improve the user experience. We're super centric on how do we make things for users. So thank you for giving us a nod to our documentation, but I always think our documentation is better. But then how do we make the NGC application smarter, right? We talk about conversational AI. We talk about deep learning-based recommender systems. We talk about NLU. How do we start bringing some of those technologies into NGC to further improve the user experience? I don't want to give too much away, but you can almost see NGC starting to use its own content that's hosted up on the catalog itself.
Right. Yeah, I have another question. Is GPT-3 available somehow to NGC?
Let me take a test run and find out. Give me just a second. Right now, we do not have GPT-3 up on NGC. Let me show you. And again, I can't even keep up anymore with the amount of models that we have on. We have
Right.
GPT-2,
Okay.
our instantiation of Megatron that's there.
Right.
Right? And it was posted in June of last year. So you do have
Uh-huh.
a model that is there, which is checkpoint based for GPT-2. But again,
Nice.
we have tons of other models related to conversational AI. Are you familiar with NEMO? The neural.
Not so.
Okay, so it's analogous to Transfer Learning Toolkit for conversational AI.
Okay.
So I think that's, you see a lot of models that are NEMO based. And again, they require kind of workflow from ASR, NLU to text to speech, right? So I think you'll find a lot of interesting artifacts and models related to those under the NEMO and conversational AI domain as well.
Right.
But GPT-2, not GPT-3.
Okay. Yes. Two is still good. Yeah. Yeah. I noticed you said artifacts. Could you help like define what is an artifact in terms of NVIDIA?
That's right. No, and that's fair. And I use that term broadly because it's when I talk about artifacts, I'm really addressing all the resources that are on NGC as a single bucket. Sometimes we use entities, sometimes we use artifacts. So artifacts is a combination of the containers, the scripts, the resources.
The collection of everything.
Exactly.
Okay, cool. Right. Okay. Right. Yeah, you've done a very good job explaining the platform. And for now, I have no further questions. And I mean, I'm very excited to give this a try. And perhaps in the future video, we could also provide like a walkthrough or a tutorial of NGC in action.
I think that would be fantastic. I think that would be great, right? Rather than just talk about, hey, we're making it super easy.
Right.
Let's do something real on the fly.
Exactly.
You tell me what the right use case is and what domain you're interested in, and we'll set that up.
All right. Cool. That would be awesome.
Yeah. So Chanin, man, I really appreciate you taking the time, and definitely look forward to more engagement and letting the world know, or letting your ecosystem know what we have to offer, how we make it really easier for data scientists and developers and researchers, of course, to some of the world's toughest problems.
Right. Yeah. Yeah. Thank you very much, Adel, for your time, and kudos to your team over at NGC NVIDIA. And you guys are doing amazing stuff. And so looking forward to the great stuff that your team is developing. And so I'll provide the links related to this talk discussion in the description of the video, and as well as the pinned comments. And so once again, thank you for being here. And it was a pleasure talking to you.
Likewise, Chanin. Thank you very much for taking the time from your end as well. And stay safe.
Yeah, you too. Yeah, bye-bye.